In the task 3, we are going to bring back the robot at the initial position. We have three methods. Either we measure the distance traveled, either we can bring it back until it reaches the blue or red and it will stop, or we can calculate the rotated angle forward and we will get it back the same rotated angle. Let's check it together. We'll start by the first method. We will measure the distance. I measured it and it was 23 centimeters. So I'm going to bring it backward in the MBO2 chassis. So move backward in centimeter until done. 23 centimeter until done. In the second method, we are going to use the quad RGB sensor in order to let the robot move backward until it reaches the blue or the red. From the MBO2 chassis category, we are going to move backward at slow speed, such as 20 RPM. It will move backward until it reaches the blue or the red. So I'm going to use the wait until from the quad RGB sensor. I will choose the quad RGB sensor text line. So here it will detect either blue or red. But which probe will detect blue or red? Random probe. Any probe detects blue or red, the robot will stop. So I'm going to use another condition. I will use the operator or. First condition, I will duplicate it and change the blue to the red. So here the robot will move backward until the quad RGB detects blue or the red. Once detected, the robot will stop the encoder mode. We'll upload it and check it together. We'll explore now the third method used by the robot to navigate back to its starting position by calculating the degrees it has traveled. To begin, we are going to reset the encoder motor to 0 degrees at the starting point. So I'm going to the category MBO2 chassis. We're going to reset the encoder motor rotated angle at the beginning, at the initial position. This will ensure that the measurements are accurate from the outset. As the robot moves toward its destination, it will record the degrees turned, which will typically increase. The key function of this method is to enable the robot to return to its initial position, effectively resetting the degrees back to 0. So it has to back to the initial position. When the degrees are set to 0, it will stop. This will allow the robot to accurately measure and correct its path, ensuring it always returns precisely to where it started. I'm going to take the move backward at 20 RPM, and the robot will keep moving until the degrees are 0. So we are going to take a parameter or operator less than 2 degrees, and I will take the encoder motor rotated angle in degrees. When it reaches less than 2 degrees, it will stop the motor and we will see that the robot will precisely return to its initial position. Let's check it together.